So in this video, we're going to talk about, whether these compounds are aromatic, non-aromatic, or anti-aromatic. Now, there are, a couple points that I want to go over first before we even touch on some examples. So delocalization. This is very important, right? And this simply means that, okay, well, the electrons, certain electrons does not belong to one particular atom. You need to know what this means, because you're going to see that these electrons actually delocalize, that they're free to roam. Okay, and in fact, benzene, we know benzene, 6-membered rings, conjugated, it's aromatic, right? Actually, benzene looks something like this in reality. All right, it's flat and it has these cloudy electron density surrounding it, right? And so these electrons in here are actually free to roam. They're delocalized, right? And so in fact, this is one of the reasons why you'll see in organic chemistry we draw benzene with this O in the middle. Okay, so delocalization is very important to know. Now, for your aromatic compounds, looking at this rule here without doing a lot of math, we're going to overcome this rule. And we're going to say for aromatics, you have to have 2 pi electrons, and then I'm going to add 4 to this, which will give me 6 pi electrons, and I increase by 4 again, which will give me 10 pi electrons, and I increase, that will give me 14, so on and so on. All right. For anti-aromatics, I start at 4, so I have 4 pi electrons, and then I add 4 more to that. That will give me 8 pi electrons. Add 4 more to that. That's 12. Okay, so notice the difference. Okay, so this is what we need to know. All right. Now, the only rule that anti-aromatic compounds, does not follow, is the idea of this 4 pi, this 4 pi 8 pi electron rule, right? So it does not follow the 4n plus 2 pi electrons, which means that instead of having 2, 6, 10, it has 4, 8, 12. That's the only rule anti-aromatic compounds do not satisfy. So let's look at a couple examples. So let's look at these 3 molecules here. Okay. Are these aromatic, anti-aromatic, or non-aromatic? Well, the first thing I look at is if my atoms are all sp2, right? This is sp3 carbon. So this is non-aromatic. We don't even have to go any further. It's not sp2, it's sp3. We can't do anything about that. So this is not aromatic. Now, what about this one? Well, remember, in order for this carbon to get a negative charge, it had to have 2 lone pairs on it. Okay. Now, this is the idea we talk about delocalization. So this lone pair actually does not completely belong to the ring, to the carbon, so it's free to roam. So actually, we could hybridize, we could fling these lone pairs into the ring to give us 4 pi electrons, and now my carbon will be sp2. Okay. So we always want to do something on paper to make sure that we're getting the most stable molecule. Okay. So whenever we can do that, we are going to do that. So if you put this into the ring, this has 2 4 pi electrons. My carbon is now sp2, but remember we said that 4 pi electrons, that's anti-aromatic. And notice that when we did this, the only rule that this break was having 2 pi electron, 6 pi electron, 10 pi electron. Instead, it has 4. That's the only rule it breaks, because once we fling this into the ring, my carbon is now sp2 hybridized. I'm conjugated. I'm flat because again, flat is implying that all my carbons is sp2, which is what planar ring means. It's conjugated. The only rule that it breaks is this. Okay, so that's the difference between anti-aromatic. That's very important. Okay, now what about this one? Well, it's flat, right? These are all sp2 carbons. I have 2 pi electrons. I have a plus charge here, which means that my carbon is now sp2, has 2 pi electrons, so this is aromatic. All right. Now what about this compound here? 5-membered rings are hard to draw. All right, so if I'm looking at this compound here, looks kind of weird, but if I look at this compound here, is this aromatic, anti-aromatic, or non-aromatic? Well, if I look, all my carbons are sp2 hybridized. You agree? I have a hydrogen here, so I have 1, 2, and the hydrogen bond, three electron groups. So all my carbons are sp2 hybridized. However, how many? All right. So which means that my system is flat. It's conjugated. How many pi electrons I have though? 2, 4, 6, 8. All right. So this is 8 pi electrons. Right. So therefore, we said that okay. Well, it has the in order for it to be aromatic, it has to have 2, 6, 10, and I increase by 4. In this case, it has 8. Okay, so this is anti-aromatic. Now, what about this one? What about this one? Is this aromatic, anti-aromatic, or non-aromatic? Well, just for you, this is actually called azulene, and this molecule here is very important. It's a natural product that is used for to prevent skin deterioration. So azulene, just to know on the side, it's pretty good stuff. Okay, now. Well, if I look, I'm in a ring here, right? All my atoms, if I look, are sp2 hybridized, right? So that means this molecule is flat. Well, how many pi electrons do I have? I have 2, 4, 6, 8, 10. Okay, so I have 10 pi electrons. All my atoms are sp2 hybridized, planar ring, which means that it's planar. I have 10 pi electrons. So this is aromatic. All right, so that's aromatic. So let's look at a couple more examples. All right, so let's take a look at these examples and let's see if we could classify these as aromatic, non-aromatic, or anti-aromatic. Okay, and let's look at this one also. So this is actually called furan, right? Is it aromatic, anti-aromatic, or non-aromatic? Well, the first thing I'm going to do is draw my lone pairs. Okay. Now you see that in the ring I have 4 pi electrons. Okay, I have 4 pi electrons. However, again, remember we said delocalization. So these electrons are delocalized. So if I delocalize 2 of these lone pairs into the ring, I now have a 6-membered ring. And look, and maybe I should draw just to be clear. Right? So if I delocalize these into the ring, and let's, for illustration purposes, I'm just going to put the 2 lone pairs here so you can see it. I still have 2 lone pairs remaining. Okay, so I have 2, 4, 6 pi electrons. And these pi electrons, okay, well, you might be saying, that's crazy. How do I do that? You're crazy. Get off YouTube. I mean, what drugs are you on? Well, I'm not on any. But the idea is, if you could somehow get very stable molecules, do it. Okay. So from the outside, this may look like it's 8 pi electrons, but remember, they're delocalized. So 2 of these electrons will actually delocalize themselves into the ring to get very stable molecule. Okay, so we have 2, 4, 6 pi electrons, and now look, my oxygen is now sp2 hybridized. It has 1, 2, 3 electron groups around it. That means that it's sp2. Prior to this, it would not be sp2, it would be sp3. Okay, so that being said, it has 6 pi electrons. It's conjugated, it's flat, and so this is aromatic. Now, what about this one? Okay, well, I see that right now my nitrogen is sp3 hybridized. Okay, you agree with me? I have 2, 4, 6. Well, sorry about that. I have 1, 2, 3, 4 electron groups around that. So I'm sp2 hybridized. Well, how many electron groups I have in the ring? Well, how many pi electrons I have in the ring? I have 4. Okay. But remember, we said that these electrons are delocalized. So anytime I'm able to get an aromatic compound with delocalizing those lone pairs into the ring, I'm going to do it. So if I delocalize these electrons into the ring, which they are in reality, they're delocalized, right? And now I have these 2 electrons into the ring. I have 2, 4, 6 pi electrons. And now look, my nitrogen is now sp2 hybridized. Okay. So that means that I have 6 pi electrons. My nitrogen sp2 hybridized. It's flat. It's planar. It's conjugated. So this is aromatic. Now, what about this one? 4 lone pairs on the ring, right? Well, without further ado, let's look at one of these carbons here. That's an sp3 carbon. We can't do anything about it. Okay, one of these electrons cannot come in here and form a double bond all of a sudden to give us, yeah, that doesn't make any sense. Okay, so the first rule it breaks is that sp2 rule. This is not aromatic. All right, let's look at this one. Is this aromatic, anti-aromatic, or non-aromatic? Well, again, let's look. We have 2, 4, right? So we have 2, 4 pi electrons into the ring, and we have 4 pi electrons outside. So from the outside, this looks like, okay, well, I have 8 pi electrons. Well, no, 2 of these electrons are delocalized, right? So remember we said that anytime we could delocalize 2 of these lone pairs to give us 6 pi electrons, or any aromatic pi electron number, right? Whether it be 2, 6, 10, 14, etc. We're going to do it. We're going to do it. So if I delocalize those electrons into the ring, now I have 6 pi electrons. My nitrogen is now sp2 hybridized. So I have 6 pi electrons into the ring. My nitrogen is now sp2 hybridized, right? Because we have 1, 2, 3 electron groups around it. So that is it's aromatic. It's planar. It's conjugated. All right. So for these problems, I encourage you to look at, is it possible to get aromaticity with the delocalization of electrons? Okay. These electrons do not just belong to the nitrogen atom. Okay. And it's the same thing with this benzene that we illustrated earlier. It's a cloud of electrons. So they're, they're circulating around in orbit in the ring. All right. So that's not aromatic. Okay. Now let's look at this one. Is this aromatic, anti-aromatic, or non-aromatic? Okay. Well, we have 2, 4 pi electrons. Right. We have 2, 4 pi electrons. We might be thinking it's anti-aromatic. Well, what's my nitrogen? My nitrogen is sp3 hybridized. Remember, in order for this to be anti-aromatic, the only rule it has to fail is this is the number of pi electrons. So this has 4 pi electrons. However, we have this sp3 carbon here, not carbon, nitrogen, which means that this is not aromatic. So again, to point out the difference between anti-aromatic is very simple. The only rule that is going to fail is this rule here. It has to have only, all right, so the carbons have to be, well, not the carbons, but all the atoms have to be sp2 hybridized. You know, it's in a planar ring, it's conjugated, but number 4, it's not going to follow number 4. Okay, that being said, let's look at another one. Is this aromatic, anti-aromatic, or non-aromatic? Well, if I look, all my atoms are sp2 hybridized. You agree? All right. So sp2, 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 sp2. Also on the other side. So that's sp2 hybridized. If it's sp2 hybridized, that implies that it's flat. It's planar. Okay. So we covered rules 1, 2, 3. The rule that we're looking at now is this pi electron rule. How many pi electrons are actually in the ring itself? Well, we have 2, 4, 6, 8, 10, 12. All right. Which means that this is anti-aromatic. Again, the only rule that it fails is this, as the 4th rule, the 4n+2 rule. Because remember we said that in order for compounds to be aromatic, it has to have 2 pi electrons. And we just add 4 to that, 6 pi electrons, 10 pi electrons, 14, and we could go further. All right, so this is aromatic. Anti-aromatic is the opposite. So it starts at 4. So we have 4 pi electrons, and then we add 4 to that. That will give me 8 pi electrons. And then we add 4 to that, that will give me 12 pi electrons. So the only rule that this fails is this 4n+2 rule. And we have anti-aromatic numbers. Okay, so very important. So let's take a look at a couple more examples. Okay, so let's take a look at these 3 examples. Are these aromatic, anti-aromatic, or non-aromatic? Well, the question we gotta ask ourselves is, okay, well, the first rule we're gonna look at is this: are all our atoms sp2 hybridized? No. This has 4 electron groups around it. That's sp3. Okay, so once we break that first rule, this cannot be aromatic or anti-aromatic. So this is non-aromatic. And what about this one? Again, I'm thinking about delocalization. I see that I have 4 pi electrons into the in the ring, but I see that these electrons are delocalized. So if I move these electrons into the ring, look, I now have 6 pi electrons, and now my carbon is now sp2 hybridized. Okay, so it's the idea that you know, if it's possible, looking at, you know, things on paper, in order, I'm going to try to get aromaticity. Okay, I'm going to try to satisfy the rules if I can, using these lone pairs as tools. Okay, so this has 6 pi electrons. All my atoms are in sp2 hybridized. It's conjugated, right? It's conjugated. So this is aromatic. And I'm drawing this on paper, but again, guys, we say that this in reality is flat. Okay, this in reality is flat, and it has a cloud electron density surrounding the top. Okay, now what about this one? Well, I look on my atoms; they're all sp2 hybridized. Okay, which means that it's flat. All right, it's flat. Okay, it's conjugated. How many pi electrons we have though? 2, 4. Okay, so 4 pi electrons, we can't do anything. We can't hybridize anything. We can't use any lone pairs because there's no lone pairs available. The molecule is just what it is. So it has 4 pi electrons. So this is anti-aromatic. All right, so that's anti-aromatic. Let's take a look at a couple more examples to kind of just get the concept. Okay, so what if I were about to look at this compound here? Is this aromatic, anti-aromatic, or non-aromatic? And also, I want to take a look at. Right. Take a look at this. Is this aromatic, anti-aromatic, or non-aromatic? Well, again, I see that in my ring, I have 2, 4, 6 pi electrons. I have a lone pair on the nitrogen. So you might be saying to yourself, okay, well, I have 2, 4, 6, 8 pi electrons. That's anti-aromatic. Right? Because we know that all our atoms are sp2 hybridized. But look what happens if you actually try to take these electrons and delocalize them into the ring. Now I'm going to have 8 pi electrons, which is not good. And then my nitrogen is actually, so let's draw it out to kind of see what I'm talking about. Right, say for example, I delocalize these electrons into the ring. Now my nitrogen is not sp2 hybridized anymore. Do you see that? It's not sp2 hybridized anymore. That's linear, right? Which does not make any sense. You cannot do that. So the idea is anytime you in the ring, you have the ring that's already, aromatic in terms of pi electrons, do not force the electrons into the ring. It's simply impossible. It doesn't work like that. Aromatic chemistry does not work like that. So these lone pairs actually have to stay inside, and they do not count towards pi electrons. Surprisingly, okay. So here's an interesting fact that you should look for. Okay, lone pairs do not count as both. In certain situations, lone pair do not count as both pi electrons, and they count towards hybridization. It's one or the other. So notice that if I localize these electrons into the ring, then I lose my hybridization. Right? If I do not, well, this is sp2 now, and my ring is conjugated. So this is 6 pi electrons, so this is aromatic, and this is this. Yeah, so this is not correct. I was just showing you an example, so don't do this, okay? So this is aromatic. Now what about this? All my atoms are sp2 hybridized. It's flat, it's conjugated. However, I have 2, 4 pi electrons. We know that's anti-aromatic. Okay. What about this? Well, I see that my oxygen right now, as it stands, is actually not sp2 hybridized. It's sp3. Okay, but these electrons are delocalized. Okay, so right, if I fling 2 electrons into a ring, I now have 2 pi electrons remaining on oxygen, which counts toward hybridization because we need those electrons to hybridize that to an sp2, and now we have 2 4 pi electrons into the ring. Well, again, we can't do anything else. So this is anti-aromatic. So a question you might be saying to yourself is, why could you move these electrons into ring and why cannot? Notice the difference, right? And as it stands, look, in the ring, it has 2 pi electrons, right? In the ring, it has 2 pi electrons, which you will say, okay, well, that's aromatic. Well, remember, it has to follow all these rules and not just one, okay? So I'm trying to look for the best possible way to try to get this to be aromatic. Okay, and if I delocalize these electrons into the ring, in order for it to be flat, I need my atoms to be sp2 hybridized. Well, this is not sp2 hybridized. So if I force it to be sp2 hybridized, now it has 4 pi electrons. It's sp2, but we have 4 pi electrons. Okay, in reality, cloud of electrons, they move around. Okay, with this, again, we cannot Okay, we cannot, because again, the ring is already conjugated, it's already stable, and these electrons will count towards hybridization, because if we move them, the nitrogen is not linear, which does not make any sense. So again, if your ring is already aromatic, okay, if your ring is already aromatic and you're looking about moving electrons into the ring, first look, if you move those electrons, will your hybridization change? In terms of, if you move those electrons, if it's already sp2 hybridized, you cannot move them. That's the idea, okay? Well, if it's already sp2 hybridized, you cannot move those electrons because you're trying to get that flat ring, okay? And these rules follow in order, okay? They follow in order. So you gotta have 1, then you gotta have 2, then you have 3, then you gotta have 4, okay? So this is all for the video. I hope this kind of helps you and clear your mind. It's pretty not that difficult, as long as you understand the concept of delocalization. That's the most trickier part, because you might be looking at compounds and saying, especially the lone pairs, you might be looking at lone pairs and say, okay, well, that's 8 pi electrons, and in fact it's 6. Well, they're delocalized. So the idea of delocalization is very important.